Hi students, welcome to Maths Point of View. Today we are going to understand the concept of scattering of light and its application. This is part C of the main chapter spectrum. In this chapter we are going to understand the concept of scattering. After that we are going to solve each and every theory question. So this is very much important. After this only you are going to understand how the questions can be framed in the exam. So without wasting any time, we'll start with our concept. Before jumping into the topic directly, we need to understand few things. See, where the light is coming from for us on earth, that is from sun, correct? When the light from the sun enters the earth's atmosphere, it will start scattering. We don't know what is scattering only, right? Scattering is nothing but spreading. So the lights start spreading. Why? Because of the dust particles and the air molecules in the earth's atmosphere. So this is nothing but scattering. Okay, so how to define it properly? So we understood why there is a spread, because of the air molecules and the dust particles present in the atmosphere. Now we'll try to combine all these data as a definition. So scattering is a process of absorption and re-emission of light energy from the dust particles and the air molecules present in the atmosphere. So what these dust particles and air molecules will do? They'll absorb the light energy and re-emit it. So the light energy will go through the dust particles as well as the air molecules. Okay, these air molecules and dust particles, first it absorbs, then it re-emits. Okay, so this is the definition of scattering of light. Next, what is the condition? See, condition is very simple. This is the condition. What is the condition? The size of the air molecules, the size of the air molecules must be smaller than the wavelength of light. Why we are comparing the size of the air molecules and the wavelength? Why? Because both the unit, see how we measure the size, using the unit meter. What is the unit of wavelength? That is also meter. That is why they can compare it. Okay, so the size of the air molecules must be smaller than the wavelength of light. This is the only condition. Okay, keep this in mind. Okay, this is very much important definition, and this is the condition. They can twist the question. If the size of the air molecules are bigger, then how much scattering you can expect? So there you have to be very careful. That is what we are going to learn at the end. What if the size of air molecules are bigger than the wavelength of light? That is what we are going to learn at the end. Why? Because before learning that we need some idea. Okay, now wavelength. What happens to wavelength? See, when the light is absorbed, light is absorbed by the dust particles and air molecules, what happens to the wavelength? Wavelength will not change. Okay, this lambda is the symbol for wavelength. So wavelength will not change. So light is absorbed by the air molecules or dust particles, correct? Once it is absorbed, again it is re-emitting. During this process, wavelength remains same. It will not change. Keep that in mind. Next, scattering is not same for all the colors. Okay, scattering mainly depends upon what? Wavelength of light. Okay, scattering is mainly depend upon what? Wavelength of light. We know a wavelength of different colors is different, so scattering is different for different colors. So for a white, violet color, blue color, yellow color or orange color, scattering is not same. Some colors spread a lot. Scattering is nothing but spreading. So some colors spread a lot and some other colors will spread least. That is nothing but scattered least. That completely depends upon wavelength. Next, intensity of scattering. How much, say after scattering, what do you mean by scattering? Spreading. What do you mean by intensity? Intensity is nothing but brightness. So we know after scattering, brightness will reduce, correct? That is nothing but intensity. See, intensity and brightness both are not same, almost related. Keep that in mind. So for now you can use intensity as brightness. So after scattering, after spreading, we know the brightness of light will reduce, correct? So how much it is reduced, what is the brightness or intensity after scattering. All those things we are going to find using the formula I. The I is nothing but intensity of light is directly proportional to the 1 by 4th power of wavelength. So based on this one, they will not ask you any numerical. Okay, 4th power is difficult to calculate, right? But this relation you should know. Okay, intensity of scattering after the light gets scattered, any color light gets scattered, what is its intensity? Using this formula we are going to find it. So intensity, how they may ask you the relation. Okay, how intensity of scattered light is related to the wavelength of a light. These two are inversely proportional. That means intensity of light is inversely proportional to the 4th power of the wavelength of given light. That's it. Next, least scattered, most scattered. See, here we have learnt scattering is not same for all the colors. It depends upon the wavelength. So which color of light is least scattered? So scattering means spreading least. Okay, that is nothing but a red color. Keep this in mind. Red color. Okay, why red color will scattered least? That also you should know. Why? Because it has maximum wavelength. Maximum wavelength. See, red color will scattered least. Why? Because it has maximum wavelength. Violet. Violet will scattered most. Okay, most. Why? Because it has minimum wavelength compared to the colors. When it comes to colors, red has the maximum wavelength. That is why it scatters least. So scattering means spreading. So spreading of red color light is least compared to violet color. That's it. And this one, if not, what if? We have learnt a condition for scattering, correct? What is that? The size of the air molecules must be smaller than the wavelength of light. What if the size of the air molecules are bigger than the wavelength of light? So what happens? Very simple, all the colors of light will scattered to the same extent. Here what we have learnt, scattering is not same for all the colors, correct? Okay, only when air molecules, size of the air molecules are smaller than the wavelength of light. So it depends upon wavelength at this condition. If this condition is wrong, okay, that means ulta. If air molecule size are bigger than the wavelength of light, then all the colors of light will scattered to the same extent. Keep this in mind. So these are the basics of scattering. After this one, okay, we are going to learn some applications. See, keep this in mind. The applications are almost, okay, like give reason type of question. During the sunset and sunrise, why the color of sky is orange or red, and why the smoke color is white, and why the space is black. All those things are give reason based on questions. So we are going to skip it, okay, during the theory solution. Why? Because we are learning in depth. Okay, this is the only chapter in where we are going to skip the give reason type of questions. Why? Because this chapter is mainly for give reason only, and that is what we are learning in this video properly. The same questions we are going to skip it in theory solutions. Now we'll understand why the sky color is different during the different times of the day. Sometimes it is red, sometimes it is blue, sometimes it is completely white, correct? That is in different times of the day. That is what we are going to understand here. Now see, we are going to learn the give reason type of questions here. So I'm going to, whatever the give reason is there in the theory solution, everything we are going to learn here only, and I'm going to teach you how precisely you have to write the answer in the exam. According to the textbook, it is very lengthy. Answers are very lengthy. I'm going to make it very short so that your answer will fetch the complete marks. So the same questions, okay, are there in the theory solution, and I'm going to teach you how to write it exactly. So that is why these give reason type of questions we are going to skip it in theory solution, because the questions are same, no change in the question, the same questions they are going to ask, and you should know a simple reason. That's it. If you know that much, that is enough to solve any give reason type of questions when it comes to scattering of light. Now listen, before going into the topic whether the sky is blue, red or white, we need to know something. Red color will scatter. Scattering means what? Spreading. Okay, so spreading of red color is least. Okay, why? Because it has maximum wavelength. Why? Because it has maximum wavelength. Next, violet. Okay, violet color is the most, okay, it will scatter the most, it will scatter the most. Why? Because it has minimum wavelength. So a color has, if a color has minimum wavelength, it will scatter more. Okay, if I see, okay, the sky color is blue, that means because of scattering of blue color light. If I see sky color is red or orange, it is because of scattering of red color light or orange color light. Keep that in mind. If I see blue color, it is because of scattering of blue color. If I see red color, it is because of scattering of red color. That's it. Okay, then few things, these are the few things we need to know. We can directly jump into the topic. So here the distance is important. So if the distance is more, okay, if the distance is more, scattering will be more. If the distance is less, scattering will be less. Keep that in mind. Now we'll understand why the color of sky, sometimes it is red, sometimes it is blue, sometimes it is white. So this is completely based on the distance. What distance? The distance from the sun to the earth. See, when during the sunset, keep this in mind, during the sunset and sunrise, okay, assume the sun is rising here and setting here, okay, both the times the distance between the sun and earth is longest. Keep this in mind, longest. So during the afternoon, sun is exactly on our head, correct? Now see the distance, only this much, correct? But any other time, sun direction, sun position will be here. See, assume at around 10 o'clock or 11 o'clock, sun will not be here, it will be in a almost like a circular shape, right? So it will move like this. So while moving, the distance from the sun to the earth will be keeps on reducing. So only during the sunset and sunrise the distance is longest. Keep this in mind. Okay, now as the distance is longest, the light rays from the sun has to travel longer distance from the sun to the earth's atmosphere. Okay, during this travel, as the distance is longest, all the colors will get scattered, but only red is visible. Why? Because all the color will get scattered to a maximum extent, so every color will be absent. It is scattered, it spread a lot, okay, it has spreaded a lot so that it is not visible. Okay, to a maximum extent it has spread, so it is not visible. So the only color which is scattered and present is red. So why? Because it has a maximum wavelength. Now we learn why sometimes the color of the sky is blue. See, during the sunset, this is the sun's position, so the distance is longest. Apart from that, we know earth will keep on moving around the sun. So while moving, the position of earth and sun, okay, will not be the longest distance. Okay, the distance between sun and earth will not be longest distance all the time, correct? So whenever the earth is moving, assume, okay, for now sunset is here, okay, assume sun is here right now, sun is here, okay, around 10:30 in the morning or 3:30 in the afternoon, all those things. So at those time, the distance is not the longest, it is long. Okay, the distance is long. This is during the sunset. Okay, this is during the 10:30 in the morning or 3:30, 4 o'clock, almost like that. So the distance is not longest, but it is long. This is very much important. Now the question is, why the sky color is blue sometimes? So now this is how you're going to answer. As the distance between the sun and the earth is longer, not the longest, you have to use the word longer. See, this is how you're going to write in the exam. As the distance between the sun and the earth is longer, blue color light will start scattering. Blue color light will get scattered. Now we'll understand why sometimes the color of sky is white. Okay, we have learned why sometimes it is red, correct? Why sometimes it is blue. Now we are going to learn why sometimes the color of sky is white. See, during the noon, okay, afternoon, what is the sun's position? It is almost above our head, correct? Almost above our head. So now see the distance. Distance is short. Okay, the distance between the sun and the earth is short during the noon, so there will be no much scattering of light, okay, will take place in the atmosphere. That's why all the light will combiningly will see it as white color. So how to write the answer in the exam? What is the question? Why the sometimes the sky color is white? The answer is very simple. The distance between the sun, everything, okay, for all the conditions I have to start from the distance only. Okay, the distance between the sun and earth is short, there will be no much scattering of light. That's it. Now we'll understand why sometimes the sky is black in color. That too mainly in space, correct? So that is what we are going to learn here. Assume an astronaut who is there on the earth right now. So he or she moves to the space, okay, and they are away from the earth's atmosphere. This is the condition. Now in the space we know it is nothing but vacuum. Vacuum means no atmosphere, correct? No atmosphere, and scattering of light, it is only possible in atmosphere. What do you mean by atmosphere? That is nothing but presence of air molecules and dust particles, correct? In space there is no air molecules, no dust particles, so no scattering. So no scattering. Now we'll see the astronaut in different position. Assume she has moved from earth atmosphere to space. Now whenever she sees up, there is no atmosphere, correct? No air molecules or dust particles, so no scattering of light. Whenever she sees left side or any other side, okay, again there is no air molecules and dust particles, that is nothing but no scattering. But light can enter from sun to her directly, correct? Whenever light can enter, okay, in this direction or any other direction, okay, so here now the light is entering from sun to the astronaut directly, correct? Because we know, sir, light rays can aram se move in vacuum, but whenever they are moving they will not scattered. So what is the color she is going to see now? White light. Okay, white light, there is no scattering. There is no scattering. Why? Because the sun's light entering directly to her. Okay, now in any other direction no light is coming. Assume there is a star here, some star here, then she can see, assume there is a star. Okay, now because the light, we know sun is also a star, right? So like that, star light from the star can enter her directly, and there will be no change in the color. There will be no change in the color. Same color she is going to see, because there is no scattering. So if there is no light source, assume in the space you are not directly seeing the sun. Okay, in that case there is no scattering of light, because there is no light also. There is no light and no scattering of light, because there is no atmosphere. But if she sees the sun directly, then she will see the light, okay, as white color. Why? Because there is no scattering of light, because of absence in atmosphere. Now assume the same astronaut sees the earth's atmosphere. Okay, what color she might see? She might see as blue color. She might see as blue color, and we know why. Sometimes we can see blue color of light in the sky, correct? So these are the possible scenarios. So what is the exact answer you're going to write for black color sky? Very simple. In the absence of atmosphere and light source, in the absence of atmosphere and the light source, no scattering takes place. That is why the color of sky is black. And they can change the question. In the vacuum or in the space, okay, you can say there is a light coming from the sun to a person, okay, a person. Now we know in the vacuum, or when there is no atmosphere also, light will travel. At that time, what is the color of the light? If you are passing red color light, you will see red. If you are passing blue color light, you will see as blue. If you are passing white color light, you will see as white. Why? Because here, even though the atmosphere is absent, light source is there. Light source is there. That is nothing but sun. If you talk about laser, the source is laser, but it will not scattered. It will not scattered. Why? Because there is no atmosphere. Okay. So these are the possible scenario. This is how you're going to write it in exam. Now we are going to understand why the color of clouds are white. See, this is completely different from why the sky was white during afternoon. During the afternoon, see, first we'll understand the difference between these two. Then I'll teach you how to exactly write the answer. See, assume this is Earth and this is the sun's position. The distance is short. So the distance is short, all the colors will scatter to a minimum extent. So there is no much scattering, correct? That is why the sky appears white. When the distance is shorter, okay, this one scattering of light takes place to a minimum extent, okay, not much. That's why the sky color of sky was white. But now we are talking about why the clouds colors are white. See, we know the clouds are made up of dust particles and water molecules. Here, the size of the water molecules are bigger than the wavelength of light. So this is completely different concept. Why the clouds are white? That is completely different concept. So you should not think anyhow the concept is about white color. You should not write the same answer. Here, the distance is shorter. Okay. So there is no much scattering. When it comes to clouds, we have water molecules, correct? The size of the water molecules are bigger than the wavelength of light. See, this is what this condition we have learned during the basic of scattering, correct? What if the size of the molecules, okay, the size of the molecules are bigger than the wavelength of light? What happens? All the colors of light will scatter to a same extent. All the colors of light will scatter to a same extent. The same thing here. Now the size of the water molecules and dust particles are bigger than the wavelength of light. So all the colors of light will scatter to a same extent. When the scattering is happening to a same extent for all the colors, we see it as white. See, when the blue color scatters most to a maximum extent, it becomes absent. Only we can see red color. Okay, if the scattering of blue color takes place to a minimum extent, to a limited extent, then we can see the color as blue. Here all the colors are scattering to the same extent. Why? Because the size of the water molecules and the dust particles in the clouds are bigger than the wavelength of light. So this much if you write, that is enough. Now we'll understand why we use red color as a danger symbol. Not only in danger symbol, whenever they talk about any question related to red color light, okay, about spreading and all, why we are using red color, why cannot we use other colors, all those questions, a very simple thing you should know. See, red color has maximum wavelength and it scatters least. These two words you have to write. If you miss any one, you're not going to get full marks. So what are the two important things? Red has maximum wavelength. See, this is the wavelength symbol lambda, and scatters least. These two words are important. Now using these two, you frame a sentence, you will get full marks. So we know red has a maximum wavelength, so it scatters least, so that it can move longer distance. See, if the danger symbol is too long also, then we can see if it is made up of any other color, because of the longest distance, okay, it scatters most, we cannot see it properly. That's why we are using red. Why red? Why? Because it has maximum wavelength, okay, it scatters least, and it can travel to so if you write this much, that is enough. Okay, if you want to extend it, it can travel longer distance, okay, with least scattering. That's it. So that it can passes through fog also. When there is a fog, mainly we use red color lasers. Why? Because red color lasers can travel through the fog because it has maximum wavelength and it scatters least. That's it. Now we have understood the complete concept of scattering of light and its application. Basic of scattering of light is important, where we can see all these things. Why the sky color is blue, black, sometimes white, why it is red sometimes, and why the smoke color. See, so when it comes to clouds, we are talking about clouds, right? clouds and smoke. Okay, smoke coming from the cigarette or chimney, anything. Why that is white? Why? Because the dust particles are the size of the dust particles are longer than the wavelength of light, so it makes all the colors to scatter to the same extent, so that it appears as white. So these kind of questions you have to be very careful, and these give reason type of questions I have taught you how to write it precisely, not a lengthy answers, precise answer. That much you write in the exam, you will get full marks. That is why these give reason type of questions we are going to skip it in theory solutions. So after this video, go for the theory solutions. Many questions are important there, so learn that also. You will be having the complete knowledge about the scattering. Thank you.